have another process called submerged arc welding process. So in this process, what happens, all the process is taking place inside the submerged condition. The arc is established between a wire electrode that is fed into the welding zone with the help of a feeding mechanism. This process is used to join very thick pieces, and the deposition efficiency or deposition rates are of very high order, and such welding process requires very high current. So due to the high current and high metal transfer rates, the generation of heat is very high, which causes the high temperature zone inside the welding area, and due to that the chance of oxidation is very high. So to prevent oxidation and to prevent the metal efficiently, you require all the process to be in the submerged condition. From one end you supply the flux in the form of powder into the welding zone, and simultaneously you supply your welding electrode, which is coming in the form of wire, and then it is touching the workpieces, and you also apply the high welding current. Now the electrode moves over the workpiece or in the welding area, and all the process is carrying out under the submerged condition. And unlike in the manual metal arc process, so you are not able to see the arc. So the arc or the establishment of arc is beneath the layer of the flux, and this process is very efficient in joining very thick pieces as compared to the manual metal arc welding process. You remember that what is the limitation of manual metal arc welding process? In manual metal arc welding process, you are using your electrodes of limited length, so you are able to produce joints of limited length, and intermediate welds are not good, because at the start, at the end of the welding, you can say the welding positions, you will have certain defects which are seen in the form of a crater. Such type of welding is not preferred for very lengthy joints or joints which require continuous welding. In such cases, the electrode is modified in the form of a wire, and you know that if you want to coat this wire with the help of flux ingredients, and if you try to wound it on a wire spool, then it will cause the breaking of that flux coating. In that condition, the external flux coating is failed. Then the question arises that how you will achieve the atmosphere to prevent oxidation and other contamination. In this case, the process is modified in the form of a gas shielded arc welding process. Here, the inert gases such as argon or helium, they are used to protect the weld pool, and your electrode is transformed in the form of a gun, through which your welding electrode in the form of a wire comes out with the pulling of the trigger. And also there is a provision of supply of protective gases like argon, nitrogen and helium. So this process helps in joining the very lengthy workpiece and to obtain weld of the continuous seam. And you have another process in this same category which is known as gas tungsten arc welding process, or its name is GTAW, and sometimes we call it tungsten inert gas welding or TIG welding process. So I have already told you that in TIG welding process we use electrode which is made up of tungsten, and tungsten is doped with some thorium to increase its conductivity and to enhance the emission of the electrons and to make the welding very efficient. And in this process, this welding electrode of tungsten is non-consumable because its melting point is about 3000 degrees centigrade. We adjust the power and current in such a way the heat generation at the electrode tip should have a temperature lower than 3000 degrees centigrade. And such welding process produce very cleaner welds and of very less defect, because you are supplying heat in very controlled amount. There is no requirement of the filler wire because it is preferred for joining very thin metal workpieces. And then we have the last welding process, which is called the plasma welding process. In plasma welding process, we supply gases which are easily ionized, and then ionization of the gases causes the formation of the plasma. The plasma has a temperature of an order of 10,000 degrees centigrade. This plasma is used to melt the pieces and join them together. So this is a brief discussion about the fusion welding process. Most of the processes we have already studied in our first year. If you don't remember all these processes, then you can refer the books of Dieter or Kalpak Jian or Groover and Kalpak Jian. And then we move to the process which comes under the category of pressure welding. In pressure welding process, it is further divided into two category. One is the process in which we require, you can say, which depends upon the frictional heat generation between the parts, and other process involves the application of the current and the resistance offered by the workpieces during the joining process. In the resistance welding process, we have spot welding process, we have seam welding process, we have projection welding process, butt welding process, and flash welding process. If you remember the spot welding process, in which we use two copper electrodes to join the thin workpieces, from the upper side and from the bottom side we apply pressure with the help of the copper electrode, and then for very small time duration we apply the current. Due to the conduction of the current, there is a gap. It basically experience the resistance between the parts to be joined. So if you remember that the parts to be joined definitely will have some gap between them, so that gap offers the resistance to the flow of the current. And if you remember the formula of Joule's heating effect, which is equals to H equals to I square RT, from that formula the heat generation takes place, and then the melting in the localized region takes place, and you form a small spot or weld nugget between the parts to be joined. And then spot welds for this process is employed to join very thin workpieces. This process is easily automized and can be seen in most of the automobile industries to join the doors of a vehicle and car. But there is a limitation of this process, that you don't get the seam or the welding continuously. You have small spots at regular intervals, so always there is a gap. There is no tightness between the workpieces. Any fluid can pass through this gap between the two spots or weld nuggets. To overcome this, we adopt the seam welding process. In seam welding process, these copper electrodes they are replaced with the help of the rollers. So now the electrodes which were in the form of cylindrical shaped electrodes, they are now being transformed in the form of rollers. The operation will be the same. You keep your workpiece over each other and then send this combination between the roller from the top side and from the bottom side. The current is applied. This idea comes from the rolling process. So if you remember that in the rolling process we have two rolls, and then you supply your workpiece to be joined or rolled. You fed them between the gap between these two rollers, and then they apply pressure on the workpiece, and simultaneously you are supplying your current to it. So now the welding produced will be composed of multiple overlapped spots, which is in the form of a seam. This is the seam welding process. In projection welding process, what we do, we take two workpieces and intentionally we create some projection over the workpieces at different locations where you want to have the joint. In the projection welding process, the sheets have already some protruded portions over the surface, and then these sheets are joined together and you supply the current between them. So the current will pass through the points which are in contact with each other. The conduction of the electrons causes the localized melting and formation of nuggets between the sheets. And in butt welding process, we have two workpieces to be joined. We bring two workpieces together and then apply the current between them. Due to the migration of the current, localized heating is caused at the surfaces which are joined together, and then you also applying pressure on both the workpieces. The pressure causes the joining of the workpiece in a very rigid form. If you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.